Hey guys and girls, welcome back to another beautiful video on this beautiful channel on this beautiful day. How you guys and girls doing? Oh my god. Today we're talking about the textures, the beautiful textures that will just enrich your life and all your objects and make it really beautiful. And it's a little complicated sometimes to handle in OpenGL to understand, but let me create an image for you how to do this. So textures are basically files on your computer. So what you want to do is you want to go into your, this is another project, YouTube tutorial, right? Go in here, create an empty folder called images, and put a picture of your choosing in here. Now, one thing to remember is that PNG files support alpha, the alpha channel, which is transparency. So all this beautiful transparency here. If there's something behind here, you'll be able to see it. JPG does not support that. So it'll be white, I think. Yeah, everything transparent will be white. One, because it does not have an alpha channel. So just remember that. Make sure you create an images folder in here where your main is and put your Pusheen or whatever you want in there. Any type of image with some alpha in it, whatever you want. Now, the way they work is I'm gonna draw a little picture for you. Just paint 3D. Let me tell you, this is behind the scenes. All right, this is behind the scenes. OpenGL. There are a bunch of attach points here, like this, that OpenGL supports. It depends on your graphics card how many of these attach points there are, but these are called texture units. All right, they're texture units. This is a texture we're gonna create. So this is our Pusheen image, right, with a cat, whatever, something like that. We're gonna load this in, all right, to something, an unsigned char array, basically from 0 to 255. Each pixel here has a color, right, from 0 to 255, which is the max. So RGBA, obviously. So 255, 255, and 255. That is red, green, and blue. So it has a bunch of those colors right here, and that's what we're loading in. We're loading this image into a unsigned char array, basically, but whatever. Then we'll create a GL texture with that, an OpenGL texture. So we'll have it created. It will have its own ID in the end and its own options and stuff. Every time you bind this ID to the actual OpenGL, this is also the background, OpenGL, this is the texture 2D bind point. We can bind it here. Anytime you bind it here, the ID, all of these options will activate because they're also related to the ID. Now this is really complicated to understand probably, but just imagine that you bind some textures that you have loaded, the IDs, to these points, to this 2D texture 2D point, and then this will be considered activated. This is the active texture. You can have several textures like that with different IDs. Depending on the one you bind, the other one will be unbound. So this is the active, currently active texture right now, this one. Now the way this works is you have to activate one of these. Either they're on or they're off. So once you put one of these on, the other ones will be off. All right. So by default, the 0 texture unit is on. Now imagine texture units being the things where you finally attach your texture. So anything bound to an active texture unit, or anything bound while a texture unit is active, you know, you can access that texture by activating the texture unit. So if I have texture unit 0 activated and I bind this texture, then anytime this texture unit 0 is activated, this texture will be, you can get this texture from the shaders. If you bind the texture while texture unit 1 is active, when texture unit 0 is active, you won't be able to access this texture. So that's the way texture unit works. Basically, they're the final say in what texture you want to get. But the way it's relevant to us that when you create an ID here, a texture, and the texture unit, while the texture unit 0 is active, you bind it and you want to draw something, you have to make sure that texture unit 0 is sent into the shader as well, because the shader works in these texture units. It takes one of them and it sees what texture is bound right now, active, and it will use that data. So you'll see this in practice. Just remember that these texture units are required to bind multiple textures to a object, basically. So I can have several textures, activate texture unit 1, bind my textures, and activate texture unit 1 bind a texture to that. And I think I said it a little wrong before. The rest do not deactivate, but nevertheless, once you activate a texture unit, that texture will be associated with it. Whatever, maybe I'm babbling too much now, but just remember that they're there. Now let me just show you how to work this. To create a texture, first thing we want to do is create two variables called image width equals 0 and int image width or height equals 0. And then we want to say remember, unsigned char array image equals, and remember we kind of linked soil, right, this library, to load images. Load image is what you want to call. The first parameter of this is the directory, so images pusheen.png. We're gonna get that in. The second one gives us, returns actually, or sets this width variable to whatever the width of this image is that we're loading. So we'll pass it by reference, image width. Same thing with height, image height. So after this function is called, we'll get these two values put into our variables. Channels, don't worry about it, just put null here. Now force channels is what we want. We want to say soil load RGBA, because our image is PNG, it uses RGBA, so I'm going to load that as an RGBA image. Once that's loaded, that's complete. Now we're going to create our ID that I was talking about, GLUint texture 0. This is going to be our texture's ID. Now the way we get an ID, and we actually create a texture behind the scenes, is we say GL gen textures. We want to generate one texture, and we want to give past the ID. We want to get an ID here from OpenGL. But alright, I generated some memory space for you. Here's an ID to this memory space. So we get it back. Boom. Then we want to say GL bind texture, because this, now we want to say, okay, we want to work with this texture 0. We want to add some stuff to it. Texture 0. Oh yeah, and we want to bind it to the GL texture 2D, or bind it as a GL texture 2D. Basically, it's a 2D texture, is an image, 2D image. You can have different types of textures, because you don't have to use a texture as an image. You can use it as a place to get data from as well, and that's way advanced. We can talk about way later. But for now, let's just take texture image 2D. And once we bind it, we want to check if our image was loaded correctly. So we'll see if image, that means there is something in here. If there isn't, we'll get an error. So we'll do else error, std cout error texture loading failed, and we'll just do this. Now before I actually set the texture data, send it to the graphics card memory, what I want to do, or set it in OpenGL, sorry, what I want to do is I want to, because that's going to happen in here, I just want to make sure I fix some stuff. I'll do GL bind texture. We want to unbind all textures, GL texture 2D 0. So this is important. 0 means there is no active currently bound texture to any texture unit or anything. There's no currently bound texture. And that's because whenever you get an ID back from GL gen textures, it will never give you a 0. It will give you anything above and 0. So if you want to see if a texture has been created and loaded successfully, or if there is a texture in here even, because sometimes you want to draw stuff if there's a texture, and if there isn't a texture, you don't want to draw it. That way you can check that if texture 0 is bigger than 0, then there's a texture in there. So yeah, just remember that. And then we'll do also GL active texture 0. That's our texture unit. We're resetting the texture unit. There's no active texture unit right now. And then I'll just want to do soil free image data, and I want to say image. Now this removes any loaded part from this image that soil has in the background. It just removes that. And image is kind of what it loaded into. So it just removes all that data for you from memory, so that you clear it out. That's important to do every time you use soil load image. Anyway, let's get back to it. If image was loaded correctly, what we're gonna do is we're gonna do this: gl text image 2D. All right, and here we're gonna set some stuff, and then we're gonna do something called gl generate mipmap, gl texture 2D, and I'll explain all of this, don't worry. But it's important that you know what a mipmap is before we really get started. A mipmap is that a thing where OpenGL takes your texture image and it makes smaller versions of it and bigger versions of it to automatically adjust depending on how far away you're looking at the texture and the object. All right, so mipmaps is basically the same image in several different sizes and several different resolutions rather. And to generate that mipmap, you just write this and it does it for you. So yeah, that's important to do. Let's see, the first thing is we want to generate a texture image that is a gl texture 2D. The mipmap level it starts from is 0 because we just want to start from the beginning. The internal format is gl RGBA. All right, the width is image width, image height, border is 0. Now this is the format is also gl RGBA. The type is important, gl unsigned byte, and this actually depends on what type this is. So it's an unsigned char. A char is also a byte big, so unsigned byte. And then we'll actually just put an image in here because that's our actual image. So now we created a OpenGL texture using our image data here that is bound to a GL texture 2D texture 0, this ID right here. So every time we bind this ID now to this point, we will be binding this image data and everything at once. One more important thing that we need to do is we need to set the options for all this stuff. So what you do is gl text parameter I, and this is actually gonna set some options for us. So gl texture 2D, that's our target wherever this is bound. All right, anything that's bound to this point here, we're gonna change stuff to it. So what do we want to change? Well, we want to gl wrap s, texture wrap s. Now what the hell is s and t and stuff like that? Well, s and t are just basically other names for x and y. All right, because this is a 2D image, this is the x coordinate, and t will be the y coordinate, I'm pretty sure. We use different names because it's important. Something just like text coordinates here, text chords. It's also xy coordinates. It's just sometimes confusing to see. And uv as well. U is x and v is y. Sometimes you'll see that, so don't get too confused. It's just another name for x and y. But what this does is it sets an option where if you're kind of over scanning, if the texture does not fit the area where you're trying to put it on, what's going to happen? Well, on the x-axis, what we want is the texture to repeat whenever it goes over. You know, there isn't enough texture to draw on that part. Same thing with the y coordinate. We just want it to repeat if it goes beyond the corners and all that stuff. Or not beyond, but less basically. If you check out the OpenGL, learnopengl.com, they have really nice images that show you how that works, and it's on, I think it's below textures or something. It's really good. Go check that out. Then we want to set some options. We want to set gl mag filter, texture mag filter. Now this is basically some kind of anti-aliasing for the texture, where if you're maximizing the texture, if it's getting bigger as the camera is coming closer or something, what kind of filter do you want to use for that? Now the explanation for those are also on learnopengl.com. There is gl nearest and gl linear. I use gl linear for mag and mipmap linear. So all the images in the Mipmap will also be processed with this linear filter, as well as the original image. I think that's what it says, basically. But you'll have to read closer on that on OpenGL.com, learn OpenGL.com. But basically, just the linear filter is nice. The nearest filter is kind of more pixely, so I usually use this. Then we want to do texture min filter, GL linear. You can play around with these and just see which one you like more. The mag is magnification and min is minification. So when you magnify something, basically you get more pixelation. If you minify something, make it smaller, it doesn't really need a Mipmap filter, so you'll just use linear normal. No filter for the Mipmap. Basically that's done. I know it's complicated sometimes, I'm sorry, but you know, we will persevere. There's also a reason you don't really have to activate a texture unit when you bind this here. Usually you want to activate a texture unit before you bind something to that texture unit, basically. But here you don't have to do that, because we're just creating the texture. We'll unbind everything here anyway. The important part is here, where we want to bind our texture when we want to draw something. Now I'll just see that this image loaded correctly, that we don't get that error. That we did not get that error. There we go. So what we want to do now is, before we draw our VAO, we want to activate texture. So GL activate texture, GL texture 0. This is the texture unit, so we want to put it in the first texture unit. Then we'll say GL bind texture to GL texture 2D texture 0. So we want to bind the texture we just loaded, and then we're going to draw this. Now it's not going to work because we're not using the texture in the fragment shader right now, but the binding should be fine. To use it in the fragment shader, what you need to do is you need to do this. You need to write uniform sampler 2D texture 0. Now what a sampler 2D is, it's kind of a picker. Imagine a hand picking pixels from, you know, one pixel at a time. That's sampler from coordinates. So it can sample some color data from this image that's loaded or currently bound. And we'll just call it texture 0 because, yeah, you know, why not? It's texture 0. Now how do we get that? This is the actual color right here, VS color. I'm just going to comment that out, and we'll say fs color equals texture. So we want to get something from a texture. Now which texture unit is that? Texture 0. And what coordinate do we want to sample? Now remember, the fragment shader runs once for each pixel, and the texture coordinates will do something that is kind of interpolated. So for every fragment there is a special texture coordinate. So for every pixel it will pick a pixel from the texture as well. So we'll just say vs text chord right here, and we'll just do that. Now this is already a vector 4, so we don't have to convert that. And if I run this, I should get a crazy Pusheen weird, something really weird happened here. Vertex core, that's really weird. Wow, okay. I'm pretty sure that's because something is wrong with the texture coordinates over here. So 0, 1, 5. I think this should be 1, 1. I'm pretty sure it should be 1, 1. Yeah, that fixed it. There you go. There you go. So we have our Pusheen loaded. Now what's happening is this is taking one pixel at a time color data from the texture. And what's happening is we did not actually send a 0 to this uniform. Remember, see, because we have this thing where we send uniforms to the shader. We're gonna have that. We're gonna use a program, update uniforms. We don't have any other uniforms. Uniforms are basically just variables you can send from the CPU to the GPU, the shader. And what we can do is we can send something here. We can update a uniform. And I'll show you how to do that just in a second, because this is important. If you have more than one texture, you're going to have to do this. For 0, you don't have to, because this defaults to 0 anyway. That is the currently active texture unit anyway, so you don't have to do anything. If you want to change this variable to 1, you'll have to send it in. But let me just show you how that works. What also I want to show you quickly before I do that is, if I just don't flip the image, it will load it upside down. That's why I flipped the image. So I set the texture coordinates the other way around, so it would kind of flip. Play around with that, see if you can get that to work in different ways. If I do GL uniform 1i, because I just want to send an integer. This is kind of, you want to send a uniform variable, 1 variable, and it's an integer. So I want to send something to a position. Now the way you check what you want to send data to is you want to get this name out from this currently bound program, our shader program. So you'll just do GL get uniform location. I want to get the location of this in memory. What ID does this have, so I can send data to it? I'm gonna say I want to get it from core program, because that's what the shader is part of, and the name is actually texture 0, and there we go. And I want to send a 0 to that. Get uniform location text from core program texture 0, and I want to send a 0 into that, because that is the active texture. I'm gonna bind my texture to the texture unit 0. That's why I want to make sure that this checks from the texture unit 0. It picks the texture from that active texture unit. Again, I'm really sorry that it's very confusing at times, but I'm gonna try to keep it simple. Now another cool thing we can do is we can actually take this color data and we can multiply it into our texture. So what we'll get then is we'll get a rainbow colored cat. Boom, easy, right? So we're just adding this pixel data, multiplying it with this other color data. So we'll kind of mix and match everything in the shader. So that's kind of cool. Play around with that as well. I recommend that for you to do that. One thing you need to remember from now and forever is that before you send data to the uniform using GL uniform, you have to bind a shader program. That's really important. All right, you need to do that. And once you're done drawing once, you actually probably want to just unbind some stuff. GL use vertex, GL bind vertex array 0. All right, GL use program 0. And the same thing with programs is that they'll never get an ID that is smaller than 1. So anything 0 will just reset everything. There's no currently bound texture. So GL active texture is also just 0. GL bind texture, GL texture 2D 0. So we're just resetting everything, and we'll bind them again in the next run anyway. So that's really important to do at times. But there we go, we have our little cat. Now I wanted to bind this to a triangle, right? Just a triangle. So if I just remove this triangle 2 and I try to bind this, what's going to happen is that it's going to kind of just have this little triangle here, and it's going to take one pixel, all the pixels in this triangle, and just draw the texture in there and the color data. So remember that, how it works. Maybe you see that. I'm not really good at explaining this, I think, because it's taking too long and I'm babbling too much. But for now, I think that's fine. That is one texture sent in. Create the texture, load it in from the image, create it, and then bind a active texture program or a active texture unit, and bind the texture to that unit as a texture 2D, then the element that is drawn, anything that is drawn will be using that texture. Any VAO you bind will use this texture that is currently drawn. And you want to send, if you have more than one texture, you want to send the texture 0. It's going to take from the 0 texture unit. And if I want another texture, all I do is this, which I'll show you in the other video. I'll probably have a GL uniform, another uniform here. So basically that's what you do. I think it's about time to end this video. I hope you learned something from this and I could explain this well enough and draw it out for you guys and girls. But yeah, keep learning. Read learnopengl.com, that ebook. I'm sure you'll understand more. Thanks for watching as always and the support, and I'll see you guys in the next one. All right, bye bye.